Hello everyone, welcome to next video tutorial on uh, data structure. In today class, I am going to explain the module 5, the graph concept. In the previous video, I have explained what is a graph and different operations on graph, then how to traverse through the graph by making use of two techniques like BFS and DFS. In today class, I am going to start with the second chapter of the fifth module. Second chapter is based on the sorting. Okay, then what is and sorting? Already we have seen the sorting is nothing but the given set of elements or numbers in a different order. We have to sort them either in a increasing order or in a decreasing order. Okay, for example, if I said uh, here I have taken one array, in that I have stored the number randomly in any order. Uh, Randomly in any order. After sorting, I have to get it in a increasing order. Like if I take in terms of array, a of 0 is less than a of 1, a of 1 is less than a of 2. Similarly, a of 2 is less than a of 3. Keep on the last number is last but one number is less than the last number. Okay, this is the concept we have seen to how to sort an element either in increasing order or in the decreasing order. In that we have two sorting technique in this chapter. uh, First one, insertion sort. Second one, radix sort. Third one, address calculation sort. And that address calculation sort is based on the hashing technique. Okay, so first we start with the insertion sort. It is a very simple sorting technique. In that we're going to make use of two dividing the entire random numbers set into two parts. The first one is an empty part. It is called as sorted list. Another one, it is taken another part. It is an unsorted list that contain the entire set. Okay, in which we are going to insert each bit, each element sort at a one time. Means at every one iteration we are going to sort only one element. So first time we copy the first element into sorted list, then second operation we fetch second one bit one element from the unsorted list. Then in the sorted list I'm going to swap it based on their order. Okay, so we keep on do this until all the elements of an set get complete. Okay, and it is less efficient compared to quick sort, heap sort, and merge sort. Why? Because for each iteration, I have to sort for a single element, so it takes time consuming as well as it is less efficient. Because of that time consuming, that is why it is less efficient and consumes more memory. That is the reason it is also considered as an less efficient compared to quick sort and merge sort. Okay. So these are a technique, and the array of values to be sorted is divided in two sets. As I told, one is sorted values, and the one is unsorted value. Then we, in the sorted value, we fetch one element from the least significant least bit. Then compare with the next value. If it is larger than that, then extend that value. Okay. In the example, we'll come to know. So I'm going to make two list one is sorted and the one is unsorted. Initially sort contain empty, unsorted is the entire sequence. So first time I'm going to fetch one element from the unsorted to sorted. So 15 will be copied to sort now. Then the next one I'm going to copy the 20 to the sort one. Then I move the cursor to the next one. Then uh, 50 and 20 already they are in the increasing order. We don't do any operation. Come for the next one. So next time I am going to fetch 10 to the sorted list, but 10 will be less than 15 and 20, so that you have to keep it in the beginning. Again, in this one you have to perform the sorting in the sorted list. Based on the value we need to perform the sorting. So initial bit, always the first bit at 0th place will be compared with up to the sorted list element. Okay, and then similarly next time I'm going to fetch 30 into that. 30 will come after 20, so we keep it sorted. So we keep on going. At the end all the elements get sorted. Okay, like here 5 we must come at beginning, so again we have to perform the sorting technique, and 5 will be placed at the beginning. So keep on do this, and at the end all the elements got sorted. Okay. Then next is how to sort an element by using an algorithm. Okay. uh, from the step 2 to step 5 you have to repeat for the same. Step 1, temporary array of k. So that initially we got the element from unsorted element, unsorted list, that will be copied to array of k. Then it will be assigned, checked with the next element. J will be next element to be checked. For example, initially I copied the 10, then that element to be copied for the next element 15. If it is first element is greater than second element, we have to perform the swapping. The array of j will be exchanged with array of j plus 1. Means here, as I told, uh, whenever I bring 10 into that, the 10 should come at the beginning. So compare this 10 element with all the element. To compare with 15 and 20. If it is less than that, you have to swap it. Keep on swap these two elements so that we get a sorted element list that will be applied for all the element. Then how many times you have to perform until the entire value of an entire elements of an second list unsorted list of completes get completes. So you have to do the same operation until the it reaches to the end of the loop. Okay. So how it works, compare with a of 0 with a of 1, then a of 1 with a of k minus 1 until the sorted element end list will get uh, compares. Okay. Then next operation is the radix sort. Radix sort, it works on based on the buckets. If I am sorting the numbers, that time I make use of the 10 buckets, 10 buckets, because the numbers are in terms of the decimal 0 to 9, so that I require 10 buckets. If I'm making use of an alphabet, that time I make use of the 26 bucket. Why? Because for each letter one bucket. So alphabetical order from A to Z, 26 letters, we require 26 buckets. Okay. How to sort it? Just like a dictionary, whenever it will two words to be compared from the first letter. If the first letter get matches, you go for second letter. Okay. The second letter, whichever comes at the beginning, that will be given as the first matching pair. Like if I take an example of uh, if you take an example of Jack and Jill, first time Jack and Jill, first letter will be J, that remains same. Second time A letter is same, that will same. Then compare C with the L. So C comes first by default. Jack will be appear at the beginning. Jill will be appeared second. In this way, each letters will be compared. So, and in order to perform the matching, we need to follow the following steps. Like we start with the three different passes, and the example I told here. If I taken this example, first you have to find which is the largest element among these given sequence. So largest element is 802. In the 802, it is of how many digits? It is of 3 digits. So the largest number with the number of digits will be applied to all other with all other numbers. Like here 15 is, I have to provide 015. For 1, you have to provide 001. Not to make all the elements is of 3 bits. Why? Because largest number is of 3 digits. So first convert it. The second step, you have to create 10 buckets. Why? Because it is of decimal number. If it is alphabet, then 26 buckets. Then how many passes we have to perform? So how many, the maximum number digits are 3, so we have to perform 3 passes. In pass 1, compare the least significant bit. The given example 802, 2 is the least significant bit, 8 is the most significant bit. In second pass, we need to check for the next least significant bit. After 2, next least significant bit is 0. Then the phase 3, we have to check for the most significant bit. Next. Okay, as a first example, it is a given sequence. In the past one, you have to matches all the least significant bit. In this example, least significant bit is if 3 digits are there, rightmost element is the least significant bit. First, you have to find this one. Okay, so in the 0 to 9 sequence, always start from the least significant bit 0. So where 0 is there, initially if I start from the first bit only, 0 1 5, so least significant is 5. So you have to copy this value into at fifth bucket, 0 1 5. Next 0 0 1, so least significant bit is 1, we have to copy at first bucket, 0 0 1. Then next the 3 2 1, so least significant bit is 1, we have to copy to first bucket. Then 0 1 0, least significant bit is 0, we have to copy in which bucket, 0th bucket. Similarly, 002, sorry, 802 2 is the least significant bit, you have to copy in second bucket. So in the red line I have showed the least significant bit and matching pair. Okay. Similarly, we have to write all remaining. Then the the output of pass one is write all the sequence one by one, 010 090 001 321 011 802 002 123 1015 109. Okay, you have to write in the same from bucket 1 to bucket 9 sequentially. This becomes output of pass 1 becomes input to pass 2. Here in the pass 2 again, we need to concentrate on uh, second least bit. Okay, second least bit is a middle one. So first 010, uh, middle one is 1, so you have to copy it where, copy it to first bucket, 010. Then 090, middle one is 9, where you have to copy, you have to copy to ninth bucket, 090. Then 001, second bit is 1, middle one is 0, middle one is 0, so we have to copy, you have to copy to 0th bucket, 001. Similarly you have to apply, then we get the pass to output. So write all the buckets one by one. Bucket 1 001 802 002 109. Then bucket 1 010 011 015. So similarly the same sequence write all of them. This becomes input to pass 3. Okay, in the pass 3 you have to find the most significant bit. Most significant bit is in the first bit 0, here it is 8, so 001 0, first number to be placed in 0th bucket, then this 802 should be placed in 8th bucket. So keep on doing this, we get the final answer. Pass 3 output is right same sequence, 001 002 010, from each bucket. At the end, just look at this, all the elements got sorted, 1 2 10 11 15 90 109 123 321 802. This is where, this is how the sorting will be done. Okay, for the pass one, initially we start from the sequence, given sequence, whatever the output of pass one will be input for the pass two, then whatever the output of pass two will be input for pass three. So at the end, pass three output will be obtained. You have to perform only 3 passes because the maximum number, 802, it contain 3 digit, so you must contain 3 passes. Okay, this is how the Reddick sort get works. Then address calculation, it works on uh, the hashing techniques that will be covered in the next class, and it is based on uh, just an example I will provide here. The sequence will be given, so if I make use of the function f of x will be less than f of y, so it always gives the first number, f of 25 minus f of, if I want to get 2, how to get it, 25 minus f of 25, so function of 2, uh, here function of 25 give first digit 2. Similarly, f of 57 give the 5, f of 48 give 4. Here, f of 37 gives first digit 3, f of 33 gives first digit 3. For two numbers we get same sequence. Okay, that will be given in the example. If I want to get 1, how to get, f of 12 will give 1, f of 25 will give 2. Okay, f of 33 will give 3. For 33 37 we have only one number, both will give f of 37, f of 33 will give 3 only. Okay, then 6 7 we don't have any numbers, that is why we are getting nil value. Then for f of 86 give 8, f of 92 give 9. The remaining no more elements are there in the same sequence, only one number is there, that time I'm taking null. For only 3 we have 2 matches number, that is why it is 2 numbers will appear, then next number is null. Okay.